This is chapter number 7, cubes and cube root. So there is a story before we discuss the cube and cube roots. There is a story about one of India's great mathematic person, that is mathematical geniuses. He was S. Ramanujan. Professor G.S. Hardy, he is also one of the famous mathematician. He came to visit him, and the taxi whose number was 1729. While taking or while driving and having talked with Ramanujan, Hardy described this number as a dull number. Okay, this is a dull number. Ramanujan did something else. He quickly pointed out that 1729 is very interesting. He argued that this is the smallest number that can be expressed as the sum of two cubes in two different ways. That is, 1729 can be written as 1728 plus 1. And this 1728 is nothing but 12 into 12 into 12, that is 12 cube. And this is 1 into 1 into 1, that is 1 cube. He also said that 1729 can be written as 1000 plus 729. 1000 is nothing but 10 cube, 10 into 10 into 10. And 729 is 9 into 9 into 9. So 1729 has since been known as the Hardy-Ramanujan number, right? And this feature was known over 13 years before Ramanujan and Hardy deduced it. So how Ramanujan knew this? Because he played with number, he loved number, and he experimented with number, right? So he found it out that the sum of two squares and sum of two cubes the numbers can be expressed like that. And there are various other patterns we are going to talk which are related to the cubes. Okay. Cubes. What are cubes? Cube is simply, if you take any number x, so multiply it 3 times, this is cube. But how did it come? Cube, let us go to the geometry. A cube is a solid figure which has all of its sides equal. So how many cubes of side 1 centimeter will make a cube of side 2 centimeter? This is 1 by 1. How can we join them so that we make a cube again with the side 2 centimeter? See, this is 1, this is 1, so it becomes 2. 1, 1 become 2, and now 1, 1 become 2. So how many of cube 1 centimeter? Side cube will make 3 centimeter. Again, let us see. This is 1, 1, 1, 3. This is 1, 1, 1, 3. This is 1, 1, 1, 3. So this is 1. This is 1, 2, 3, 4, 5, 6, 7, 8. So this is 8, and this is 27. So these are called perfect cubes or cube numbers. They have come from cube, right? Because the name has come from cube. So how to find it out? Just take the number, multiply the number 3 times. For example, you want to find out the cube of 5. So 5 into 5 into 5 will be 125. 9 is 9 a cube number? See, 9 can be expressed as 3 into 3. But we are lacking one more 3 to make it a cube. So 9 is a perfect square though, but it is not a cube, right? So there is no natural number which is multiplied 3 times so that you can arrive at 9. But for 8, if you multiply 2 into 2 into 2, 3 times, you get 8. If you multiply 3 times, you get 27. So that is how we conclude that 9 is not a perfect cube. So these are all the cubes from 1 to 10. 1 is 1 into 1 into 1. 2 is 2 into 2 into 2. 7 is 7 into 7 into 7. Right? These are all 7. This 7 cube will be the cube of 7. 9 into 9 into 9. 9 9 is 81. 81 into 9. 9 was a 9. 8 9 is 72. So 729 is the cube of 9 which is shown here. Right? There are only 10 perfect cubes from 1 to 1000, as you can see here, right? 1 to 1000. You can also find it out between 1 to 100. See, this is 1 inside 100, inside 100, inside 100, below 100 means this 5 into 5 into 5 is 125. So below 100 there are 1, 2, 3, 4 perfect cubes. So let us see that when we cube, when we have number as even, the cubes are also even. When we have odd, the cubes are also odd. So we are odd, so are our cubes. We are even, so our cubes are also even numbers. Odd means odd, cubes will also be odd numbers. Right? Consider one more thing. 1 in the ones digit. You need to find the cube of each one of them. Like 20, say I say 11. 11 into 11 into 11. What do you get? 11 11s are 121. Then you multiply 11 again. So 121 and 121. So you get 1331. Did you get 1 here? Right? So ones digit of the cube number having 1 is also having, means the cube is also getting 1 at the ones number. So you can explore ones digit of cube with 2, 3, 4 also. So find the ones digit of the cube of each of the following numbers. This is ones digit, this is ones digit, all these are the ones digit. There are certain interesting patterns with cube. When we add consecutive odd numbers, say this is 1. So when you add 3 and 5, 3 after 3, what is the odd number? 5. So when you add 3 and 5, you get 8. You get 7, after this 9, then 11, you get 27. 13, 15, 17, 19, you get 64. Likewise, you get 125. This is nothing but 1 cube, this is 2 cube, this is 3 cube, this is 4 cube, and this is 5 cube. Okay? Cubes and their prime factors. Prime numbers are those numbers which are divisible by themselves or 1. So just consider these prime factorization of the numbers and their cubes. See, 4, 2 into 2, this is 4. 2 into 3 is 6. This is the prime factorization of a number. But the prime factorization of its cube will be, see, this is 4 cube. So 4 cube is nothing but 64. 64 can be written as 2 into 2, 4. 4 to the 8, 8 to the 16, 16 to the 32, 32 into 2 is 64. But you can combine these two. You can combine these two. So this is 2 cube, and this is 2 cube. 2 into 2 can be written as 2 square. 2 square into 2 can be written as 2 cube. The powers add. The powers add. So this is 2 cube into 3 cube. Again 5, 15. 15 into 15 into 15 is 3375. You can combine 3. You can combine 5, 5, 5. 3 cube into 5 cube. Similarly for 12 cube, see, 2 into 2 into 2, 2 cube. 2 into 2 into 2, 2 cube. And 3 into 3 into 3 is 3 cube. So just observe that each prime factor of a number appears 3 times in the prime factorization of its cube. So as I just suggested, that in the prime factorization, if each factor appears 3 times, then we say that the number is a perfect cube. 216, is it a perfect cube? Let us see. 216, divide it by 2. So you get 108. Divide by 2, you get 54. You divide by 2, you get 27. Divide by 3, you get 9. Divide by 3, you get 3. Divided by 1, 3, you get 1. So 2 to 2, one combination, this is 2 cube. 3 to 3, this is 3 cube. So it can be written as 2 cube into 3 cube, that is 2 into 3 whole cube. Why? Because a to the power m into b to the power m gives you a into b to the power m. So 2 into 3 to the power 3, that is 3 into 2 is 6. So this is 6 cube. Similarly with 729, if you do it in the same way, 3 into 3 into 3, 3 into 3 into 3, this is 3 cube, this is 3 cube, combine them 3 into 3, whole cube, you get, this is a 9 cube. So this is 9 cube. Again 500, let us see 500. 500 if you divide, you get 2 into 2 into 2, 5 into 5 into 5. So you are not getting 2 into 2 into 2, I just said 2 into 2 into 2, but it is 2 into 2. Here you get 5 cube, but here you get only 2 square. So now this cannot be a perfect cube. It has to be 2 cube to make it as a perfect cube. So 500 is not a perfect cube. Is 243 a perfect cube? 243 is 3 into 3 into 3, 3 into 3. So let us combine them in triplets. This is a triplet, but this cannot be a triplet. We don't have a 3 here, right? So 243 is not a perfect cube. So you can just try it out. I'll take one example, say 400. 400 let us take. Divide by 2, you get 200. Divide by 2, you get 100. Divide by 2, you get 50. Divide by 2, you get 25. Divide by 5, you get 5. So 2 into 2 into 2, this is triplet. This 2 is left behind. This is also not making any cube. So this is 2 cube into 2 into 5 square. So until unless we have cubes, this cannot be a perfect cube. You can try it others also. Smallest multiple, that is a perfect cube. So let us take an example. Now Raj made a cuboid of plasticine. Length greater than height of cuboid are 15, 30 and 15, right? So Anu now asks how many these cuboids can be taken to make a perfect cube. Now can you tell? Let us see. 15 into 30 into 15 is the volume of the cuboid. Now let us try to find the prime factors. So 15 is 3 into 5, 30 is nothing but 2 into 3 into 5, 15 is again 3 into 5. Let us combine them in triplets. So we have a 3 here, we have a 3 here, we have a 3 here, right? Now we have a 2 here and we don't have any combination of 2. 5, we have 5 here, 5 here and 5 here. So 5 into 5 into 5, 3 into 3 into 3, but we have only 1, 2. So if we multiply 2 and 2, we get 2 cube. This 2 2's and this is 1 2. So you get 2 cube. So 2 into 2, this 4, this is what is needed. Therefore 4 such cuboids are needed to make a cube. Is 392 a perfect cube? If we just factorize it, we get 2 into 2 into 2, 7 into 7. But we are lacking one more 7 to make it a perfect cube. Right now it is not a perfect cube. Now the second part of the question is, find the smallest natural number by which 392 must be multiplied so that the product is a perfect cube. So we saw that we have to multiply it by 7. So just multiply 392 by 7, 2744. This will give you 2 cube into 7 cube, that is 2 into 7 whole cube, that is 14 cube. So now 14, this 2744 is the cube of 14. Is this number a perfect cube? If not, by which smallest number or natural number should this be divided so that the question is a perfect cube? Let us find it out. 53240. 53240 can be written like this: 2 into 2 into 2, 11 into 11 into 11 into 5. If you want to find the factors, it will be like this. Now, this 5 is the number which is not forming the cube. So if we divide whole by 5, this also by 5, we can cancel it out, and this 53240 by 5 will give you a number which is the perfect cube. So this 53240 divided by 5 gives you 10648. This is the perfect cube in this case. 1188 is a perfect cube. Let us find it out. 2 into 2, 3 into 3 into 3 into 11. Now this 3 into 3 is giving you a perfect cube, but 2 into 2 into 2, we are lacking 2. We are lacking 11 into 11 here. So if not, by which smallest number should this be divided so that the quotient is a perfect cube? So if we can get rid of 2 into 2 into 11, we can find that this number will become a perfect cube. So divide it by 2 into 2 into 11. So when you divide it by 2 into 2 into 11, that is actually 44. You get 27, which is a perfect cube, that is 3 cube. Is this number a perfect cube? Let us find out the factors. So you get 2 into 2 into 2, you get 5 into 5, you get 7 into 7 into 7. This is 7 cube, this is 2 cube, but this is 5 square. So you need 5 more. So find the smallest number by which this be multiplied to get a perfect cube. So you need to multiply it by 5. So 68600 multiplied by 5 will give you 5 cube into 2 cube into 7 cube. This is 2 into 5 into 7 whole cube. 5 into 10, 10 sevens are 70. So this is 70 cube. So you have to multiply it by 5. Cube roots. What are cube roots? If the volume of the cube is 125 centimeter cube, then can you find the length of its side? In order to get the length of the cube, we have to find a number whose cube is 125. That is, a number which is multiplied 3 times can get you 125. So x into x into x you want to get 125. So what will this be? 5 into 5 into 5. So x is the number, the length of the side is 5. So how to get it? You know that 2 cube is 8. So we say that if you take the cube root of this or cube root of 8, you get 2. This 2 to the power 3, the cube root is this one, and this is nothing but 2 to the power 3 to power 1 by 3. This cube root, it is written like this, cube root, like this. So this is nothing but to the power 1 by 3. So 3 gets cancelled, you get 2. This is the cube root of 8, you get 2. So this is how we denote the cube root. So just consider these. 1 cube, inference is simply cube root of 1 is 1. 2 cube is 8, so if you take a cube root of 2, you get cube root of 8, you get 2. You get cube root of 3, you get 27, cube root of 27, that is 3 cube, you get 3. So you are taking cube root of 27, that means you are taking cube root of 3 to the power 3 to the power 3. So 3 to the power 3, this is cube root, so it is this power, 1 by 3. So you get it cancelled, you get 3. So the statement is simply like this: 9 cube is 729, you take cube root of 729, you get 9. Cube root through prime factorization method. So how to find cube root through this prime factorization? Just consider 3375. When we take the factor of these, you get 3 into 3 into 3, 5 into 5 into 5. This is 3 cube, this is 5 cube. So you know a to the power m into a to the power say n gives you a to the power m into n. Or you can say this power gets added, n plus n. And when you say a to the power m and b to the power n, you get a into b to the power m. So 3 into 3 to the power 5 to the power 3 can be written as 5 into 3 to the power 3. So now when you take a cube root of this 3 gets cancelled, you get 3 into 5, that is 15. So similarly, to find cube root of this, first we have to factor these. Prime factor means prime numbers need to be in the factor. So 2 into 2 into 2, 3 into 3 into 3, 7 into 7 into 7. This is 2 cube, this is 3 cube, this is 7 cube. So when you combine this is 2 into 3 into 7 to the power 3. So this is nothing but 7th is a 21, 21 into 2 is 42. So you take cube root, that is cube root of this, which is actually the power of 1 by 3. The 3 gets cancelled, 2 into 3 into 7 is 42. Find the cube root of 8000. So 8000, the factors are like this. This is 2 cube, this is 2 cube, this is 5 cube. Just take 2 from here, take 2 from here, take 5 from here. 5 into 10, 10 into 2 is 20. Similarly, for the cube root of 13824, you find the factors. These are the factors. You take 2 from here, 2 from here, 2 from here, 2 from here. Means from the triplet you take one number, but it has to be a triplet. If any number which is not forming a triplet, you cannot find the cube root through prime factorization. So this is 2 into 2 into 2 into 2. This is 4, 4, 4. This is 2 into 2. And this is 3, sorry. So 2 into 2, 4, 4 is a 8. 8 is a 24. 24 is the cube root. Cube root of a cube number. So if you know the given number is a cube number, then how to go about it? Just take any cube number, say this one. So in order to find out the cube root, you have to start, or you have to make groups in triplets, that is 3 digit, starting from the rightmost digit. That means from here, rightmost. The first, what we'll do here is, first group will be 375, then second group will be 857. So we can estimate the cube root of a given cube number through this step-by-step process. We get one is this one, the other is this one. These are the two groups of 3 digits, triplets, 3 digits each. So first group, that is 375, will give you the one digit as this is 5. So this ends with 5. So the 5 has to come in the unit place. So if you have a unit place and a 10 place, first we have known that 5 has to come here, right? So we get 5 in the unit place. This is how we deduce it. Now the other number is 857. 857, we know that 9 cube is 729 and 10 cube is 1000. So 857 lies between 729 and 1000. So 857 is between these two. So in the one place of the smallest number 729, we place it as the 10th in the tens place of the required cube root. See, this is what? 729, which is nothing but 9 cube. So we place this 9 here. So 95, this is our cube root. This is how we find out the cube root. I'll take one more example. See, this is 17576. We have to find out the cube root through estimation. So what we'll do, we'll combine 576, means we have to start from the rightmost digit, and then we have to take 3 digit, and 576 will be for the first one. The second is 17, but we have to make a group of 3, so we'll just leave it like that. Now 576, this 6 can only come when you have 6, this 6, so this 6 can be taken in the ones place. So 6 is our ones place. We take ones place of the cube required cube root as 6, so this is 6. Now take 17. Now 17 lies between which two numbers, which two cubes number? So 17 is greater than 8, 17 is less than 27. 27 is the cube of 3, 8 is the cube of 2. So 17 actually lies between 2 cube and 3 cube, right? So the smallest number among 2 and 3 is what? It is 2. So we take 2 here. So 26. 26 into 26 into 26 is indeed 17576. Therefore 26 is the cube root. So what we have discussed, these are known as Hardy-Ramanujan number, because these can be expressed as sum of two cubes in two different ways. A number which are obtained when a number is multiplied by itself 3 times are known as cube numbers. For example, 1 is 1 into 1 into 1, 8 is 2 into 2 into 2, 27 is 3 into 3 into 3. So if in the prime factorization of any number each factor appears 3 times, then the number is a perfect cube. This cube root is represented by this sign. It denotes the cube root. For example, cube root of 27 is 3, which is nothing but 27 is 3 cube. When we take a cube root, that means we are taking to the power 1 by 3, 3 cancels, it becomes 3. So this is all about cubes and cube roots. Thank you so much and take care of yourself.